Hey team, it's Mr. Z, and we're going to review all of quadratic forms and continue to compact them together. All right, at the top you can see these is the three forms of equations you're going to see. Standard form, factored form, vertex form, over and over and over. And we've gone over the key information about how A is concave up, it looks like so, concave down, like so. This also tells us whether the vertex is a minimum or the vertex is a maximum. But this guy is the big one. The y-intercept is always the c value. Looking at the same thing, factored form, I can say it for this one. If a is positive, it is going to be concave up with a vertex that is a minimum. We don't know about the vertex, but we know it's going to be a minimum. Likewise, concave down is going to have a maximum. Notice how by drawing the U, it helps me pair which word belongs to which concavity. Here, the x-intercepts and the roots are always going to look like so. Notice how in factored form, I have to have it in the form of division. So if it's addition, I should rewrite it in order to easily export the information. And then finally, the last one, vertex form. The vertex is always HK. And then this is the big part. I want to just reinforce that the axis of symmetry is x equals h. And all it's trying to say, let's say for it to be concave up and the vertex is a minimum, is here. When it says this axis of symmetry is at h, x equals h is a vertical line that is going to cut my quadratic in two congruent pieces. So that's what this is saying. What they want you to add to your information is that at the vertex, we can draw a vertical line, and this will cut my quadratic into two symmetrical parts. AKA, it's called an axis. A y-axis is a vertical line, but this is an axis of symmetry where the left and the right side are equal. Okay, let's go ahead and try to use some of this information to make conclusions. I am not going to be using any graphing calculator apps to help me. I'm going to go ahead and analyze this function g of x. And I see parentheses, right? Whenever it's a product of parentheses, I know that it's going to be factored form. Now, I am going to take a moment to rewrite g of x in an equivalent form, but the only difference I'm going to do is I'm going to write it as x minus, I have to make sure it's still equal to positive 5, and I use an extra color to make the root stand out, x minus 3. I do this on purpose. I do it to make sure I'm successful. Now, is the graph concave up or concave down? The number in front is positive, so it is going to be concave up. It is going to have a minimum. And since it's a half, I want to make it smaller. It's going to be compressed vertically. What are the roots of this function? Immediately it's asking for these guys. Now, I know that the numbers are -5 and 3. And you might be wondering, is it like this? Or is it going to be like so? I don't actually remember, Mr. Z. Well, remember, a root is an x-intercept. An x-intercept. Where is the 0 in the x-intercepts? Here, it's a -x comma 0. Here, it's a positive x value comma 0. So I know that this is not going to be an x-intercept. It's going to be a y-intercept. So I just wanted to preview that. Most of you are pretty good at identifying the roots, but on the fly, you might put the 0 in the wrong spot. In order to remember it, visualize an x and y coordinate graph, plot a couple x-intercepts, and see where the 0 is going to always lie. Let's repeat again. Now, I see this exponent of a 2, and that's usually what's going to be a tip-off that it's also degree 2, but this is in vertex form. Vertex form is going to tell me about the vertex. The vertex is going to be always HK, but like above, the inside of the parenthesis is always going to be x minus, I rewrite it as -5 squared plus 3. The graph is going to be concave up. Heck yeah. No, concave down. Why? It's a negative. What is the vertex? Awesome. The reason I rewrite it is it's a lot easier. -5, comma. Let me put this in color. +3. Now finally, what is the axis of symmetry? It's always going to be the x value of the vertex. So it is x equals -5. What this essentially means is this graph is concave down. The vertex is going to be at -5, 3. And at -5, there's going to be a vertical line. All right, keep on going. This last guy is in standard form. Standard form is essentially simplified form. Is the graph concave up, concave down? It's going to be concave up because it's positive. And I know that since it's being doubled, it is going to be expanded, stretched. What is the y-intercept? It's always going to be the last number. It is not just 3. If you want to know where the zeros are, draw a xy graph, plot a y-intercept. Let's see, this is going to be 0, 3. Okay, I know where to go. For these two, it's about knowing what form is going to make your life easier. When I have to write a quadratic function f of x that is concave up, and it has zeros, this word zeros screams out to my soul that it's going to be factored form. Let me go ahead and write it. F of x is equal to a times x minus root 1 times x minus root 2. Now, let me go ahead and plug in some information. It needs to be concave up, so it means that this a value is going to be positive. I'm going to just write +1 just for the sake of it. Now, I'm going to go ahead and plug in my zeros. It's going to be x minus. The first one is going to be -3. The second one is going to be x minus 4. And then the last step in my process is something should bother you about that last line in the function. Notice how it's a double negative. We're going to simplify that for our final answer. If I had to submit a formula to a boss, I'm going to go ahead and just rewrite this as x plus 3 and x minus 4. Even though I omitted the a value of a positive, since there is none, we're assuming it's a positive 1, and I know that this quadratic function is going to be concave up. All right, number 5. Now it gives me this piece of information where it says the axis of symmetry is x equals 4. This right here I get from the vertex, which means vertex form. So let's go ahead and take a look at what vertex form. F of x is going to be equal to x a times x minus h squared plus k. I'm going to go ahead and plug in some information. So it says it's concave up. I'm going to make it a +2 this time. It has an x equals 4. Now, since this is an axis of symmetry, what it's essentially saying is x is equal to h. So I know that h is going to be 4. Now, it does not give me a k value, so I'm able to generate it at will. I'm going to make it easy. I'm going to say +1. Voila! This is going to be a quadratic function that is concave up. It is going to also have an axis of symmetry of x equals 4. And then this last piece right here, it's like, oh, why is it a +1? Well, they didn't really specify, so I was able to fill in the last piece of information myself. Keep it simple, folks. All right, this last guy is a bunch of review. Can you combine operations? We got to keep our skills sharp. So I'm going to go ahead and distribute this k squared into both of these. So it's going to turn out to be 5k. How many k's do I have? 3 plus 2 is going to be 5. plus 4k's. How many are initially there is going to be 1. 1 plus 2 is going to be 3. I'm going to keep this going, and I have to just remember that it's not just 3 being distributed, it's a negative 3, and it's going to turn into negative 3k to the 3 minus 12. I forgot the k. Now, let me simplify. 5k to the 5th minus 1k to the 3rd minus 12. And if I was feeling spicy, I could remove the coefficient of 1. In number 7, I have to remember that I have to multiply before I add. My order of operations, even though we're way past this, it still is in effect. I always have to multiply and divide first. So in order to multiply, I prefer to solve my area model. I'm going to go ahead and write 5m minus 4m squared and 3. You can also use FOIL. I'm going to multiply these guys, and I'm going to get a product of 5m cubed, 15m, negative 4m squared, and negative 12. So I'm going to just rewrite this all out. I'm taking a moment. Notice how I wrote negative 4m instead of the 15. It's because I want to write everything in descending order. Now I'm going to combine like terms. Voila. Notice how this is going to be a degree 3 because it has the largest exponent as 3. All right, final one. Do I multiply or do I apply this exponent? And it's apply the exponent first. When I apply the exponent for something complicated, I'm always going to rewrite it as expanded form. Now, I would recommend multiplying all of this stuff first. 3x plus 1 times 3x plus 1. Again, I'm going to use an area model. 3x, 1, 3x, 1. This is going to be 9x squared, 3x, 3x, 1. So it's going to be 2 times, what's 3x plus 3x? 6x. And then turning into 18x squared plus 6x plus 1. All right, this was a review. I'm going to zoom out for all of you guys so you can pause the video and take notes. Good luck.